Wall systems. Principles of enclosure. Enclosure is the term given to any part of a building that physically separates the external from the interior environment. It is often referred to as the building envelope, although enclosure is considered the more precise term. The physical component of the building enclosure include roof system, above the grade wall system, including windows and doors, below grade wall system, the base floor system. The principle of building enclosure were defined by the building scientist Neil Hunchon in 1963. It should have strength and rigidity, control of heat flow, control of airflow, control of water vapor flow, control of liquid water movement, stability and durability of material, fire, aesthetic consideration, and cost. Burnett and Straub said enclosure is a separation between the interior and exterior environment that experiences a variety of loadings, including but not limited to structural loading, both static and dynamic, and heat, air, and moisture loads. The enclosure must then control these loads and support these loads. This includes both short-term and long-term loadings. The enclosure can also be used to carry or distribute some services within the building. In addition, the enclosure will have several static attributes which can be summarized as finishes. Burnett and Straub have defined 4 general building enclosures function categories. All enclosure elements have to provide the following function. Support. Enclosures including exterior wall system must be capable of withstanding an internal and external forces applied to them. The majority of these forces are in structural loading. The loads include both static and dynamic loading, including but not limited to dead load, live load, wind load, earthquake loads, and possible blast loads. These loads have to be properly supported, resisted, and transferred. Control. Enclosures, including wall system, have to be able to control mass energy particulate flow within across the system. This includes but are not limited to heat, air, moisture, smoke, odor, fire, blast, bird, and insect. Finish or statics. The finish function of both the exterior and interior is the statics of the finished surface, the visual, textual, and the other aspects the designer wishes to convey with the visible elements of the system. Of the enclosure, wall system typically have the largest consideration for finish. Distribution of services. The function relates to the distribution of services through a building, both within a single element and also through multiple elements. The definition of a wall is a high, thick masonry structure forming a long rampart or enclosure chiefly for defense. It's also a structure that serves to hold back pressure as of water or sliding earth. It's one of the sides of a room or buildings connecting floor and ceiling or foundation and roof. It's from Merriam-Webster Dictionary. There are different basic wall types. We have the cavity wall. Cavity wall is a wall formed by the inner skin and outer skin of masonry, sometimes referred as leaves if they are single unit or wide, connected by ties but separated by a cavity. The masonry is formed by units such as brick, stone, or block. Very generally, it is the external wall of the building are less than 30 centimeter thick. They are unlikely to be included a cavity. Cavity wall insulation is used to reduce heat loss through a cavity wall by filling the air space with material that inhibits heat transfer. This immobilizes the air within the cavity, preventing convection and to substantially reduce space heating cost. We have also the barrier wall. The barrier wall is used to refer to a system of externally wide assembly that maintains weather tightness by preventing the intrusion of air, water, and vapor. Barrier wall rely on integrity of the outermost surface and construction joints and are considered a cost-effective alternative to cavity or solid wall assemblies. The cladding material should be impervious to the elements. Common examples of barrier wall system include single skin metal wall panel, solid metal wall cladding, precast concrete panel, insulated metal wall panels, exterior insulation, and finishing system. We also have the mass wall. A mass wall are walls that are made of concrete block, concrete insulated concrete forms, masonry cavity brick, earth adobe, and solid timber or logs. So this is a cavity wall. This is a barrier wall. And these are the mass wall. A curtain wall is defined as thin, usually aluminum frame wall containing infills of glass, metal panels, or thin stone. The framing is attached to a building structure and does not carry the floor-to-floor loads of the building. The basic concept of cladding system, we have the load-bearing wall and the curtain wall. The load-bearing wall, these are walls that act as part of the structural system. They assist in supporting a building. Until late in the 19th century, all large buildings were built using load-bearing walls. Modern-day load-bearing walls usually utilizes higher strength masonry and concrete and added components such as steel reinforcing, insulation cavities, flashing air barriers, and vapor retarders. Load-bearing walls are now used in low and medium-rise buildings. The curtain wall, the concept of the curtain wall was developed in the late 19th century with the advent of skyscraper design. In a curtain wall system, the interior structural system supports the load of the building. The exterior wall of each floor does not support any load except its own weight and is attached at each story of the building frame. The exterior cladding is virtually a suspended curtain of material. Curtain walls may be constructed in place or prefabricated beforehand. They can consist of masonry, concrete, metal, and glass. The primary function of cladding, it keeping the water out, preventing the entry of rain, snow, ice into the building, and water is driven inwards by many forces as wind, air, pressure, differential, and gravity. Water problems are more acute in taller buildings. It also prevents air leakage, preventing the unintended passage of air between the indoors and outdoors. Smaller air leaks waste air-conditioned air. Water can carry through the walls and allow sound to infiltrate. Large air leaks can cause an imbalance of air distribution within the building. Primary function of a cladding, it's controlling light, controlling sunlight to strike a balance between useful illumination, detrimental effects such as glare, fading of material, and damage to skin. Light control can be provided by a combination of window quantity, exterior shading devices, and types of window glass use, and interior blinds and curtains. It also controls the radiation of heat. Interior surfaces can cause discomfort as they heat up in direct sunlight. Shading devices like thermal insulation, thermal breaks, and insulated glass can all be used to control radiant heat. The primary function of the cladding also is controlling of conduction of heat. Resisting the conduction of heat into and out of the building requires insulation and avoidance of thermal bridges. Thermal insulation requirements often are specified by municipal codes. It also controls sound. Acoustically isolate the interior of the building from the sounds of the outside. Sound requirements will vary by building type and location. These are the components of a curtain wall. We have the building structural elements, the fixing to slab edge, the curtain wall mullion, and the curtain wall transom, and the panel or glass. The curtain wall mullion or the vertical component, we have the curtain wall transom, the horizontal component, and the glass or the cladding finish. It can be glass, metal, aluminum. We have also different types of cladding. We have the fabric veneer, we have the stone veneer, and we have the panel. It may be aluminum, aluminum composite, or copper. So secondary function of the cladding, it resists wind forces. Cladding should provide adequate strength and stiffness to resist pressure and suction due to wind. Pressure and suction will vary by building height and where on a given building the air pressure differential is acting, such as on the corner versus the facade. It also controls water vapor. Cladding should resist diffusion of water vapor into the cavity walls and the resulting possibility of condensation. Condensation can cause loss of insulation, insulating value, corrosion of metal, and decay of wood components. The also secondary function of the cladding is for movement like thermal expansion and contraction. Cladding should accommodate movements due to changes in temperature, changes in thermal expansion, and contraction of the inside and outside building facades of the cladding itself, thermal expansion and contraction of the building frame. It also has the function for moisture expansion and contraction. Bricks, building stone, concrete, and wood all change dimension due to the change in moisture content of the air. Cladding should also be able to accommodate this. It also the function also is for structural. Structural cladding should adjust to the structural movements in the frame due to building foundation settlement, shortening of columns, racking caused by wind and earthquake forces, long-term creep of concrete. As you can see here, it's the shortening of the column. This is the spandrel beam deflection. This is the wind and earthquake deformation in case of earthquake. This is the spandrel beam deflection. And this is the differential foundation settlement and the differential spandrel beam deflection. So this should also be addressed by the cladding. Address in movement. So the cladding should have a capacity for this movement. So the structural deficiency of the cladding system can be result in the broken glass, buckled cladding, sealant failure, broken cladding attachment, failure of the whole wall. So if the cladding should be strong enough to address all of this movement. So it also should have a resisting fire capacity or what you call this characteristic. There are a number of buildings code provision relating to the construction of building exterior wall system with respect to fire safety. So it also have the function of the cladding is also for weathering gracefully. Cladding must weather gracefully. Dirt and grime should not detract from the aesthetics. Cladding must resist oxidation, UV degradation, breakdown of organic materials, corrosion of metallic components, chemical attack, and freeze-storm damage. So it means that the cladding should be what you call this maintenance can also be maintained. No? So you can clean the cladding so that it can lengthen its time in appearance. So there are these are the conceptual approaches in water tightness in cladding. 3 required conditions for water penetration. We have the water. Water must be present on the facade of the exterior wall for it to penetrate into the wall. So there should be water in order to have a penetration of water inside the building. So number 2 is the 4 openings. If there is an opening into the wall must also be present on the face of the exterior wall for the water to penetrate in the wall. So if there is a presence of opening, so the water can penetrate into the opening. And there is a force or some sort must be present on the exterior of the building to force the water into the opening, such as penetrating into the wall. Okay, so there should be a force like a wind or air, that will force the water to penetrate to the hole or to the openings. And also gravity. Gravity is another factor in pulling water through the wall only if the wall contains an inclined plane that slopes inward. Designing inclined planes to drain away from the exterior is an effective approach to deal with water penetration through gravity. As you can see the drawing, it should be the inclination should be to the outer side of the panel, not going inside of the panel. Another one is the force momentum. The momentum of the falling raindrops can drive water through the wall only if there is a suitability-oriented hole that goes completely through the wall. Providing a cover to each joint or designing a joint as a labyrinth can neutralize water driven by the momentum. As you can see, if it's a clear opening, the water can go penetrate. But if there is a labyrinth type opening, the water will not penetrate because of this labyrinth opening. So another one is forces surface tension. So surface tension, the surface tension of water which causes it to adhere to the cladding component in defiance of gravity can allow water to be drawn into the building, providing a simple drip on any underside surface that the water may adhere to helps neutralize these forces. As you can see, if there's no drip mold on the upper part of the cladding, the water can penetrate inside the cladding. If there is a drip mold, the water will drip before penetrating inside the cavity or the opening. Another one is the capillary action. Capillary action is the surface tension effect that pulls water through any opening that can be breached by water drop. This force can be dealt with by making openings in the walls wider than the water drop by providing capillary breaks or by applying a coating or silicone-based water repellent to the opening. So as you can see, this is almost like the drip mold, but this one, it's because of the capillary action, so that the water will not penetrate going inside the cladding. So another one is the air pressure difference. Wind currents can cause air pressure difference to be higher on the outer side of the building. Cladding on the other side of the wall, on the other side, drive air and rain into the wall. This is the most difficult condition to deal with. In designing a watertight wall, but it can be effectively neutralized by employing pressure equalized wall design. So as you can see, there is a pressure equalization chamber at the other side of the wall. Another one is the rain screen cladding and pressure equalized wall design. Pressure equalized wall designs allow air pressure difference to equalize. Involves air creation of an airtight air barrier. The air barrier is protected by a rain screen, which is unsealed labyrinth joint layer. The pressure equalization chamber is located between the rain screen and the air chamber. And the PEC must be divided into smaller compartments to prevent cross current. So as you can see, if this is the inside, inside of the panel, and this is the outside of the panel. So if there is a leak, that it can penetrate inside the what you call this, the paneling. If there's a sealant, it will prevent the panel to go inside, and the labyrinth connection will also prevent the panel to go, the water to go inside. Another one is the pressure equalized wall design. A labyrinth type rain screen, an airtight barrier, and a compartmentalized pressure equalization chamber. Same as the previous detail that was shown. Okay. So this is also the pressurized equalized wall design. So rain screen cladding, pressure equalization in the residential window. As you can see, the weather strip acts as the airtight barrier. The open joint under the sash rail is provided with a capillary break and act as the PEC, or the pressurized equalization chamber, and the L-shaped joint between the sash and the seal act as a labyrinth rain screen. So this is the correct way to put a what you call a pressurized equalization chamber. This is the weather strip. If the weather strip is at the back part, the water will penetrate. But if the weather strip is on the front part, the water will not penetrate. Okay. So this is positioning of the weather strip. So this is the back part. This is the front part of the section. So pre-screen cladding and pressurization equalize wall design. So refers to the system that have internal drainage regardless of the level of compartmentalization and the degree of pressurized equalization.
The FW150 series is one of the most advanced and innovative curtain wall systems developed and engineered by ESC. The patented profiles, latches and spring-loaded mechanisms provide a complete, easy and safe curtain wall system, making its installation efficient and cost-effective. Mullion installation. Installing the mullions and making sure they are properly aligned has never been this efficient. The mullions are fitted with teeth plates, which allow each mullion to be aligned accurately and effortlessly. For extensions, the mullion expansion profiles provide a tight, accurate fit with adequate space for expansion and contraction. Our specially designed rubber gaskets are also installed on the mullions from the inside of the structure. Transom installation. Unlike conventional systems, the transom is attached to the mullion with the use of the spring-loaded transom latch, which supports more weight and can be installed from the inside of the structure with unmatched speed and the highest level of safety. A rubber gasket is also fitted between each mullion and transom to compensate for expansion and contraction, reduce stress on the brackets, and eliminate noise. On both ends of the transom, a water drainage system is installed that channels the water away from the glass panels and into dedicated drainage channels within the mullions. This eliminates the time and labor-intensive method for water drainage in conventional systems. Our specially designed rubber gaskets are also installed on the transoms from the inside of the structure. Efficiency. This overall method of installation reduces the time needed to install the transoms and the gaskets from the outside using conventional cradles, making this the fastest stick system on the market for high-rise buildings. Glass panel installation. Our patented spring-loaded latches are pre-installed in the U-channel of the glass panels. While installing the glass panels, the latch system snaps perfectly into the mullions and the transoms, speeding up the installation without the need of screws that can break and be skipped during conventional installation. An additional gasket is installed between the glass panels in a dedicated channel to tightly fit the panels together and dramatically reduce the application of silicone filler from the outside. For insulation, a thermal strip can also be installed between glass panels. This reduces heat induction between the exterior and the interior of the structure. For aesthetics, a pressure plate can be installed on top of the thermal strip. Window shutter. Our patented window shutter technology proved to be more secure than conventional stay-arm systems. The window shutter is fitted with a concealed hinge. It carries the weight of the glass panel while ensuring stability and safety. The hinge is concealed for aesthetic purposes. A restriction arm secures the window opening according to requirements. Maintenance. For maintenance or replacement purposes, a special key and plate are used on the perimeter of the panel that needs to be replaced. The panel is easily removed with minimum time and effort with no damage to surrounding panels. The transoms can be removed and replaced with minimum requirements without the need to alter or damage other mullions or transoms, effectively reducing time and cost. The FW150 series means less labor, less machinery, less transportation, and is quickly, easily and safely installed. It is the most cost-effective, innovative aluminium system on the market.
As a leader in the curtain wall industry, we work on buildings from towers to campuses and incorporate features such as angles, curves, lighting, and metal accents. But what is curtain wall? Curtain wall is a high-performance building facade, the envelope surrounding the structure. It's critical to both the functionality and energy performance of the building. But it's more than that. It's the first impression, the face of our client's business and their brand. It is the thumbprint on the skyline of our cities. So, how do we install curtain wall? At Harman, we primarily install UCW 8000, our high-performance curtain wall system, which is fabricated, assembled, and glazed at our 4 manufacturing facilities across the U.S. Manufacturing in a controlled environment versus in the field reduces the impact weather can have on the install schedule, allows us better quality control, and requires less time in the field. The completed glazed units are shipped ready for installation to the job site, normally packed in bunks of 4 units each. These deliveries are sequenced with the install schedule so that typically only 1 floor of units is delivered at a time, reducing the amount of space required on site to store material. At the job site, the first step is to install the anchors that will be used to place the curtain wall. We use total station surveying equipment to precisely and efficiently set layout points for the curtain wall anchors. Once installation is complete, they are marked blue so the other trades know they can complete the steps outside of Harman's scope. The curtain wall units are then staged in sequence and lifted into place using a crane either from the ground or from inside the building. As each unit is raised, team members guide it into place. One of the benefits of curtain wall is that the installation requires only a small install crew of typically 6 team members, which helps to keep manpower costs at a minimum. Once the unit is placed, it is locked into the curtain wall anchors and adjusted to fine-tune the elevation. The placement is then checked for accuracy using a site level or rotating laser. A weather-resistant sealant is applied to each of the curtain wall seams. This helps to create one of the most airtight, weather-resistant building facades available today. Next, fire protection foam is cut to fill the gap between the floor and the curtain wall unit. In the case of a fire, the foam helps to contain the fire to one floor, rather than moving to the next floor above or below. Smoke seal is then applied to the foam to cover any small gaps. Finally, we complete the interior by placing the sill brackets and installing the windowsill extension, also known as stool trim. The stool trim gives a finished look to the curtain wall system. It is hammered into place to ensure a tight fit, and then cleaned to remove any residue. A temporary coating is applied to protect the metal during the interior construction process. This sealant is simply peeled off once construction is complete. With more than 6 decades in the construction business, we bring our high-quality standards, a culture that insists on safety at every level, a process based on collaboration, and a constant desire to find new ways to do things smarter to every project we work on. This is what makes Harman one of the most trusted partners in the country to bring building facade projects from design to reality.
These are the different types of curtain wall installed in actual project. We have the Burj Khalifa in Dubai. It's a unitized panel within the surface area of 1.2 million square feet. It comprises roughly about 28,000 prefabricated panels. It's double-layered glass set within extruded aluminum frame. Another one is the Enterprise Square, Leighton Road in Hong Kong, China. It's the Enterprise Square, the 27 office tower, 27-story office tower, semi-unitized curtain wall, operable windows, louvers, and curved feature covers. Splayed glass is clean. The contract value is about $1.4 million. Another one is the Calakmul, Santa Fe, Mexico. It's a 4-sided structural stick system curtain wall, aluminum panel for 6-story office, ornate office building and exhibition center with award-winning design. The contract value is about 1.6 million US dollar. Another one is the Chenglong Plaza. It's a unitized curtain wall, 29-story building, full curtain wall envelope, high-performance glass and aluminum panels. The contract value is about 3 million US dollars. Another one is a twin 46 and 44-story office tower, which is the Lipo Center in Hong Kong. It's a stick wall curtain with vents. The contract about $4.5 million. These are our references.